I hope you did the Punnett square. So here is the answer to that. So we draw the Punnett square here. Male will have normal vision, so male will carry a dominant allele on the X chromosome, and the Y chromosome has nothing. The female will be heterozygous. That means it will be one X chromosome carry the dominant B, uppercase B, and the other X chromosome will carry the lowercase b. And we fill out the Punnett square. This will be uppercase B, uppercase B. This will be uppercase B, Y. This will be uppercase B and lowercase b. This will be lowercase b and then Y. So what is the chance they will have a colorblind daughter? So daughter is X chromosome. So it is this one, daughter is this one, daughter is this one. So you can see that in this case, you have uppercase B, uppercase B. That means this daughter will be healthy and normal. This daughter has uppercase B and lowercase b. This daughter will be a carrier. So the colorblind daughter, what will be the percentage? That means you have 0% chance to have the colorblind daughter. Because you have 50% chance to get the normal healthy daughter and 50% chance to get the carrier daughter. So that you have 0% chance to get the colorblind daughter. What will be the colorblind son? Look at this. This is uppercase B. That means this son will be healthy and normal. And this is a lowercase b. That means this son will be colorblind son. In other words, you will have a 50% chance to get a colorblind son. So the answer to this question will be 50%. So that is the answer. For this question, 50% chance will be, you have 50% chance to get a colorblind son. You have 0% chance to get the colorblind daughter. Okay. Let's continue. So you will have a normal, and then this is what happened. It is the better, I would say, a better drawn Punnett square. Is the same result that we saw from previously. So for X-linked disorder or sex-linked disorder, more female than male will have the sex-linked disorder. The reason is that, as I said, for male we only need to have one allele, then we will express that disorder. The reason is that the recessive allele, most of the time the recessive allele carries a disorder, but not always. We just need one recessive allele on X chromosome in male, then it will be expressed the disorder. As we said, that we assume Y chromosome do not carry any allele. So usually the disorder is passed from grandfather to grandson. That means it is you will skip one generation. And the daughter of the male usually is the carrier. So we have this scenario. The grandfather has this disorder because it expressed in this case, the color blindness. And then the next generation, the daughter will get it. The daughter will be the carrier. The son, perhaps the son is the normal one. And then the daughter will transmit the transmit the recessive allele, pass on the recessive allele to the grandson. Similarly, if the healthy son married the colorblind wife, they will also have the colorblind son. So, but in this case, you can see that the daughter is the carrier, and then you will pass on the colorblind allele to the grandson. That's why it will skip one generation, and most of the time it is the male that will get the color blindness. And then, other than the sex-linked recessive disorder, we also have the dominant disorder. But only a few of the dominant disorder we'll talk about. So if the male has this dominant disorder, only the daughter will have the 100% chance to inherit this disorder. Female can pass the dominant allele to both son and daughters. An example is this one in continentia pigmenti. It's the discoloration of the skin. It is not very common to have the X-linked dominant disorder, but the X-linked recessive disorder is more common. We focus on color blindness. 8% of the male will have it. Most of the time is the red-green color blindness. That means we won't be able to see red color or green color correctly. Duchenne muscular dystrophy. Duchenne muscular dystrophy is basically the muscle muscle degenerate, so that you will have a weaker muscle that will cause your movement disorder. All this movement disorder, gait, toe walking, frequent falls, and it is because this disorder causes the absence of a dystrophin of the protein, and that causes the muscle to degenerate. So you can see the under the microscope, normal muscle looks like this. It has a lot of fibrous tissue, but it is abnormal muscle. Abnormal muscle has a lot of fibrous tissue, but normal muscle, you have a lot less fibrous tissue. So you can see that in the abnormal muscle, people with the Duchenne muscular dystrophy, the muscle cell become smaller because you have more fibrous tissue instead of, you have less muscle cell. In here, you have more muscle cell, the density is higher, so that the muscle will be stronger.